Yellow is the color of my true love's hair in the morning when we rise. In the morning when we rise, that's time. That's the time I love the best. Bluest color of the sky in the morning when we rise. In the morning when we rise, that's time. That's the time I love the best. Greenest color of the sparkling corn in the morning when we rise. In the morning when we rise, that's time. That's time I love the best. And mellow's a feeling that I get when I see her. When I see her. That's the time. That's the time I love the best. And freedom's a word I really use when I see her. When I see her. That's the time, that's the time, that's the time I love the best.
Five friends are sitting in a common room, algebras, if you will. Two of them engaged in a heated game of chess, while the other three struggle to find a real solution to their mathematics problem. What about this?
You can't do that.
This is impossible.
Are you sure? This operation solves the problem exactly.
This is impossible. What's wrong?
What do you mean?
There's simply no solution. Look.
Let's think about it.
Are you sure you wrote down the question correctly?
Yes, I'm sure this was the question.
So,
Okay.
you know that x squared is always greater than or equal to 0.
And we know that the graph of x squared, it looks like this.
But -1 is over here, so it's impossible.
Are these all the rules we have?
Yes.
Well, let's see what the rules of chess have to say about this clear violation of tradition.
Come on, I'm sure this move will win the game. Just let me play it.
Oh, no. See here, it clearly states that
Yeah.
this is an illegal operation.
Right, but what makes an illegal operation illegal? With this move, we'll solve the problem and make the game much more interesting.
How exactly do we go about making rules for chess?
Well, it's clear to me, we have to write a new rulebook. Rules had to be created once. Who's to say that we can't seek novel solutions to traditional problems?
Who are we to rewrite the rules of chess? I mean, operators, these rules have existed for thousands of years.
But as we learn more about certain concepts, new solutions to supposedly illegal operations should come to make sense to us. And since this rule makes sense to us, it'll have to make sense to other chess players too.
No, that's absurd. Magnus Carlsen must really be turning in his grave.
Yeah, certainly, sure. But we don't have to remain locked in Magnus Carlsen's moments of brilliancy. We can create our own.
You are a few inches from me.
Yes, I am. While we're at it, let's make even more rules. Let's set the board again and play with the mind of creating new rules, but within the current chess framework.
Wait, what if we make new rules for this problem as well?
You mean like change the equals to a not equals to?
No. Let's just use our imagination.
An indeterminate number of years ago, three of the most famous mathematicians to ever live are arguing about the reality of complex numbers. They are joined by another mathematician whose inability to imagine has left him out of the history books. A modern day person, real world person, is observing their conversation.
I have a question, guys. I'm stuck on this problem. I keep on getting square roots of negative numbers as answers.
That's impossible. Are you sure you worked correctly?
I'm quite sure I did everything correct.
So you are telling me you've worked correctly and yet you still encounter the square root of negative numbers? Impossible.
You do know that not long ago we didn't even believe in negative numbers themselves.
And your point is?
Well, perhaps we should think of extending our number systems once again. You know when we said that 0 would be useless or we'll never even use negative numbers? I think we should learn from our past mistakes and be more open-minded.
But how would we use this?
And how would that help me?
Well, let's say we have numbers such that they were the square roots of negative numbers. I think it could work.
Yes, I think it could also work. Would that mean that x squared plus 1 has 2 roots?
That sounds quite correct. Let's define it as follows. We can say that I is equal to the square root of negative 1, which means I squared is equal to negative 1. We should just make sure the details work correctly, but I'm sure it will work.
Yes, I also think so. I read a theorem a long time ago that x squared plus 1 should have 2 roots. This theory is filling up the roots.
But what would we use this for?
And what do we call these numbers of yours? Complex numbers inspired by your overreactive imaginations? Wait, I have an idea. Let's call them imaginary numbers instead. They're all in your head anyway.
I think this could actually work.
This is amazing.
No.
But what would we use this for?
It can't be. They can't be consistent. No. This, I'm telling you, it'll be buried in the graveyard of bad mathematical ideas. Nobody's going to use these complex numbers of yours anyway.
Why would you want to call them complex numbers? It will just confuse people for the next hundreds of years.
Look, Adano, I think it all looked rather consistent. I think this is actually correct. This might actually work.
Fine. Let's just call them imaginary numbers and get it over and done with.
But what would we use these for? Yeah. We find ourselves back in this common room. However, now with the knowledge of complex numbers, our 5 friends are well equipped to tackle more complicated problems.
Alright guys, I hear this complex numbers thing, but what could we possibly use complex numbers for in the real world?
There are many things that they're useful for.
I don't know. This thing makes me feel trapped in my thinking. Like, I'm stuck inside a box in my head and I cannot escape.
Like you need to think outside of the box.
Exactly, Imaginarics.
Well, you know, the real world is made up of stuff. Well, matter, if you want to sound more sophisticated. Matter is made up of tiny particles, things like protons, neutrons, electrons. Well, to be precise, they really aren't just particles.
What do you mean, they're just particles? What on earth does that mean?
It means they aren't just particles.
Is it particles or waves?
It's actually both.
It's either particles or waves. Pick one. What are you guys turning science into? A marketing game?
No, every particle just acts like a wave. The wave part just tells us what the probability is of finding that particle in a specific space. Each wave has a value, magnitude. We call it the amplitude.
How does one do that? I mean, find the square of a complex number?
You multiply it by its complex conjugate.
Complex conjugate. Just stop. This is getting way too technical for me right now.
Well, the actual probability of finding a particle is just given by the amplitude squared.
So you're saying it sounds like something you learned in quantum mechanics?
Yes,
Like a particle in a box?
almost like you're thinking.
So what is this particle?
What does a particle in a box have to do with the real world?
Can it ever escape?
It has a lot to do with it. Imagine a particle, say an electron trapped in the nucleus. Say an electron in an atom attracted to the nucleus. There's a force keeping the electron bound there. It's effectively trapped there.
Yes, but can it actually escape?
Yes, if it has enough energy.
How does that relate to my question about the real world? I asked that question like 1,000 times.
Well, in quantum mechanics we have waves, and the waves have amplitudes which are complex numbers.
These waves show up literally everywhere in the real world. Everything you touch, see, hear are made up of these particles with complex waves. They're literally everywhere.
Maybe this is getting a bit too much for negativists at the moment. We should stop, but it's really not that difficult. We can just show you.
But I mean, there are simpler, more familiar examples too. It's not just quantum mechanics that uses complex numbers. I mean, every time you listen to music, you are, in a sense, hearing complex numbers.
I thought they were just signals of cosine and sine waves.
Yes, they are. But just as you can write 4 as 2 squared, you can write the waves as complex conjugates.
And by using complex numbers and exponents, you open yourself to a whole new box of operations. My friend, your whole world is made of complex numbers. You just never seen them.
Yes. Each key, imagine an electronic piano. So each key produces a different tone. Volume control changes the amplitude of the keys by the same amount. That's basically how real numbers affect signals.
Oh, so all of us at some point have actually encountered complex numbers.
Yes!
Oh, I think I'm finally starting to accept that we do have complex numbers in our real world. But to be honest, I don't understand all of it.
But that's fine. I think knowing they exist is the cool part.
And you know, now we know that x squared plus 1 definitely exists.
Sometimes, in order to understand a new concept, all you need to do is broaden your horizons and have an open mind. Thank you.
So no one told me life was gonna be this way. The math is broken, understanding's MIA. It's like we're always stuck for hours on the same old problem over and over and over again. And then complex numbers is your imagination. Complex numbers, they don't seem real, but they are complex numbers. It is minus 1 square root. We we know from history mathematicians got stuck too. Bombelli, Gauss, Cardano, and some others too. They transcended and they made new rules. Society said no, but in the end, it's simply true. And then complex numbers, use your imagination. Complex numbers, they don't seem real, but they are complex numbers. It is minus 1 square root.
Complex numbers, it could be our imagination playing games with us. It could be just an illusion, but try to think of it. All the cool stuff we could do with it. Square root all the negatives, now we can get away with it. Oh, that was just too much to change, don't you think? I mean, like all of the sudden it's now valid way. All these years of really studying, doing maths, try to understand now. Everything's just a mess.
Okay, hold up. Just like vibrations in your coffee cup, come on, don't just fill it up. Let it overflow, let those cages go. Imaginary constant eye, let your thoughts fly. A whole new dimension, did we mention?
Complex numbers, use your imagination. Complex numbers, they don't seem real, but they are complex numbers. It is minus 1 square root. Complex numbers, use your imagination. Complex numbers, they don't seem real, but they are complex numbers. It is minus 1 square root.
Yellow is the color of my true love's hair in the morning when we rise. In the morning when we rise, that's time. That's time I love the best. Bluest color of the sky in the morning when we rise. In the morning when we rise, that's time. That's a time I love the best. Greenest color of the sparkling corn in the morning when we rise. In the morning when we rise, that's time. That's time I love the best. And mellow's a feeling that I get when I see her. When I see her. That's time. That's the time I love the best. And freedom's so when I really use when I see her. When I see her.